Welcome to the Adirondack Sky Center and Observatory. There's nothing more inspiring than the night skies in the Adirondacks. It just makes sense to start your visit to the wilderness above with us. Our current programs focus on immersive experiences for audiences of all ages. They reach as close as into our own community and as far away as students from around the globe. From inspiring presentations given by some of our friends as world experts, to our Keystone 4-day astrophotography conference, there's something for everyone, including live as well as virtual stargazing, customized programs for schools, and private events. In the case of the Adirondack Sky Center and Observatory, the sky is certainly not the limit, but only the beginning. A second building is currently in the planning stages in the form of an Astro Science Center and Planetarium. This 18,000 square foot building will be dedicated to the study of astronomy and space travel. The planned $15 million Astro Science Center will feature a state-of-the-art planetarium under a 30-foot dome, a 100-seat theater, and a large area for hands-on and interactive activities. Our many exhibits will include a Foucault pendulum, overhead models of the solar system, and historical permanent as well as traveling collections. It's our mission to make this an immersive experience for everyone. You will never be told to look and don't touch. This new building will be in addition to our existing roll-off roof observatory, which houses 4 permanently mounted telescopes. The final phase of construction includes a traditional observatory dome housing a new 22-inch research-grade telescope. Please contact us to become a member or make a donation to help build this new Astro Science Center and Planetarium and begin your journey to the wilderness above. And with that, I'd like to welcome everybody, our friends. It seems like we've got a community growing here, so many familiar faces that we have month after month, and some new ones as well. My name is Seth McGowan, and I'm the Vice President of the Adirondack Sky Center and Observatory, and I'll be your host and moderator for tonight. This is our November edition of the Cygnus series, presented by the Adirondack Sky Center and Observatory. Look for us on the web at adirondackskycenter.org or on Facebook at Adirondack Sky Center and Observatory. Search for us there. Before we begin, you'll notice that your mics are muted. If you haven't already done so, please do that again now. After our presentation tonight, we'll have some Q&A. And as always, our presentation will be available within a few days on our YouTube channel if you search for Adirondack Sky Center and Observatory. But tonight, we have our featured presentation by David Aguilar. David is an astronomer, author, planetarium director, lecturer, and past media director at the Harvard-Smithsonian Center for Astrophysics. Not to mention space artist and Grammy-nominated musician with a unique ability to open minds to the vast frontiers of space and their potential effects on our own world. His expertise lies in sparking intricate yet fascinating connections between the universe, nature, and ourselves. Through the development of global study tours, space science books, media consulting, and provocative lectures, which you'll soon see, he contributes to some of today's leading space science exploration programs. We're very pleased to have with us tonight for What is a Planet? David Aguilar. David, take it away.
Thanks, Seth. Let's take a look here and share our screen. Continue and does that look good?
Not yet. I think we're still on my
title
slide.
How about now?
Command. Oh, there we go. You got it. All right. And now, yep.
Bingo. Hey, welcome everybody. Thank you for joining tonight. I must say, for me, this is a unique opportunity because I love the planets more than anything else. I love Pluto. And I want to share tonight with you a very unique viewpoint of what a planet is, what a planet isn't. And this is really basically attached to the work that I do. I get to do a lot of lectures. I get to travel. And one of the questions people always ask me is Pluto a planet? So my experience, first of all, is meeting with the general public and working with them and still answering this question that's almost 15 years old now and giving them an answer that makes them feel happy, but oddly enough, makes them think. Now, I must share with you that I'm an author and I've written quite a few books on the planets. So this is one of the reasons why I've been so intimately involved with Pluto. I've done Planet, Stars, and Galaxies, 11 planets, which morphed into 13 planets, which was a little controversial at National Geographic with the decision that Pluto wasn't a planet anymore. 7 Wonders of the Solar System, and my latest book that has just come out, Space Encyclopedia, a tour of our solar system and beyond. So I've had experience researching, working with our solar system, but I've also had some other rather odd opportunities. Going back to 7 a.m. Eastern Standard Time in the Johns Hopkins Auditorium on July 14th, 2015, after 4 hours of traveling through outer space from the New Horizons spacecraft, I was also one of the first human beings to ever see what Pluto looked like as the first image traveled through space for us to ponder. There it was. That's Pluto, up close and personal. So being part of the New Horizons team and working with Pluto opened my eyes and my thoughts as to what is a planet. As we know, Pluto had been demoted. I also came back 2 years later and worked on the New Horizons flight to Ultima Thule, the farthest object in our solar system, located in the middle of our Kuiper belt of the object in outer space, something that we had never seen before. And I must say, working on this team was a blast, because not only did I get to meet some incredible astronomers, I met some pretty good musicians too. But I also worked at Harvard just prior to that, and one of my dearest friends was Dr. Brian Marsden. I spent many a dinner, many an hour in Brian's office talking about Pluto, because Brian, as the past director of the Minor Planet Center at Harvard, was an advocate for getting rid of Pluto. In 2009, he had published a report that said Pluto should be demoted and reclassified as an asteroid. In fact, he had saved asteroid number 10,000 as Pluto because he saw it as nothing more than a space rock floating through space. Funny story about Brian. In our auditorium, we had the symbols for all the planets around the auditorium, and Brian would periodically run out and take red tape and put it over the symbol for Pluto because he didn't think it was a planet. And sadly enough for Brian, 10 minutes later, it would be removed by somebody else. But Brian was adamant that Pluto should not be considered a planet. Coincidentally, across the hallway from Brian was Owen Gingrich, historian emeritus there at Harvard, who also felt that Pluto should be a planet. And so for me to go back and forth between these two offices and hear the remarks about should planets include Pluto, should they not, it was amazing. I want to tell you a funny story about Owen. He's showing you right there, that book that you're seeing. That is an original copy of Copernicus's tables and charts. I walked into Owen's office one day and I was doing a little research on Galileo. And I said, Owen, when Galileo wrote Starry Messenger, what did it look like? I mean, what were the images that he had put down in Starry Messenger? And Owen said to me, well, sit down. Opening up a gigantic wall safe that I'm certain came from a bank, he unwrapped a package, put it in my hands and said, there you go. First edition, Starry Messenger, Take a look at Galileo's work. That's Owen Gingerich. As a journalist, I see stories like this every day. The 7 rocky planets orbiting TRAPPIST-1 may be made of similar stuff. Astronomers may have spotted a planet in another galaxy for the first time. And as a scientist and a journalist, I know that these headlines are incorrect. They're wrong. They should say the 7 rocky planets orbiting, they should say objects, the 7 rocky objects orbiting TRAPPIST. Astronomers may have spotted an object in another galaxy for the first time, because, ladies and gentlemen, we don't know what the definition of a planet truly is. And that's one of the problems that we have in today's science. Now, for the next few moments, I'd like to lay out what a planet is and isn't so that we can answer this question: what is a planet? To begin, I love science. I love the process of science. Science builds on past information and science changes. Now, I know most people think science is going to be like Spock. It's logical, cold, hard, never any excitement in science. But I got news for you. Scientists are people too. And the politics that we see in the world today is no different than the politics that takes place in the scientific world. Science is not cold, hard, and removed and logical. Sometimes it can be very illogical, but it's just the way science works. The beginning of science was the study of classifying things. Back in the 1700s and the 1800s, everything was classified. We could know the difference between a squirrel and a bird, the difference between a starfish or a tree, a flower or a cloud, a volcano, a mountain, a molehill. We knew the difference between all of these because we classified them into categories. We knew the different types of rocks: metamorphic rocks, igneous rocks, sedimentary rocks. We knew the elements that we put into categories, and we could identify over and over again. Even the parts to the atom were identified and labeled. And no matter where you went in the universe, these labels applied, especially to the elements and to atoms. When we take a look at astronomy, we have all of these words that we use in everyday language, and they mean something to us: comets, moons, asteroids, nebulae. All of these objects are identified, and the beauty of them is it doesn't matter if you're in our solar system. It doesn't matter if you're in our Milky Way galaxy. We're still going to use these same terms to describe objects that occur universally throughout the universe. The Milky Way has red dwarfs. M51 galaxy has red dwarfs. Andromeda galaxy has red dwarfs. They're everywhere. But the problem today is the definition for a planet only applies to our solar system. It doesn't apply anyplace else. And there's a reason for that. And now let's take a look at what that reason was. If we go back and look at definitions that we've used in the past, I picked up my Webster's 9th edition college dictionary, and it said a planet is taken from the Greek word wanderer. Any of the 7 celestial bodies, the sun, the moon, Mercury, Venus, Mars, Jupiter, and Saturn, that in ancient belief have motions of their own among the fixed stars. Go back, look at that. They considered the sun and the moon to be planets because the word means wanderer. Many in science today still stick to that same definition, and that may have caused some problems because things have changed. Look at part B. It's one of the bodies except a comet, meteor, or moon that revolves around the sun in our solar system. The sun. We're going to come back to that because this is very sun-centric, human-centric definitions of what a planet is. Now, when I was a kid growing up in grammar school, we used to go up to the blackboard, write on the blackboard, and the definition was a planet is a round ball that orbits around the sun. That worked for about 400 years. But again, It's connected with our sun. The best of both worlds today, our solar system would look like this. We would have the terrestrial planets made out of rock and water. We would have the giant gas giants out there with methane and ammonia and water. We would have the ice giants like Neptune and Uranus. And then we would have the dwarf planets. Now, let me remind you something odd about dwarf planets. The universe loves to make things small. The most abundant galaxies out there are dwarf galaxies. The most abundant stars out there are dwarf stars. So maybe the most abundant planets out there are dwarf planets. All of this started, this whole dilemma as to what a planet is, when we discovered in the early 1990s that the Earth had been hit by an asteroid that destroyed the dinosaurs, and it could happen to us. Realizing our fate may hang on our ability to detect an asteroid approaching the Earth before it hit, we began surveying the heavens looking for these marauders. No one wanted to go the way of the dinosaurs. And it just so happened in 2005, Dr. Michael Brown detected another object beyond Pluto, bigger than Pluto. When he made his announcement on April 13th, 2006, it caused a firestorm. But it was an unexpected firestorm. He thought it was a remarkable discovery that there may be another planet beyond Pluto out there in our solar system. But what it set off is shown here in The Guardian. The little rock causing a galactic storm. It's been named Xena after the warrior princess. By the way, it was his daughter that named it Xena. But the only fighting involved with Xena is between scientists bitterly divided as to whether she is our latest planet or a jumped up asteroid. I never thought of it as a jumped up asteroid, but that's a nice description. I had been told by some of my European astronomy friends that they were a little jealous. They were a little jealous because Clyde Tombaugh in 1930, an American, had discovered the latest planet in our solar system, Pluto, and now apparently another American had discovered a planet in our solar system. So leading up to this, the International Astronomical Union meeting in Prague had seen that this was a problem. And so they had invited and put together a committee to make recommendations as to what a planet is, because it had all started with Brian Marsden when he published the report feeling that Pluto should be an asteroid. The IAU was inundated with the public requests that leave Pluto alone. Take your hands off our Pluto. Pluto is a planet. So they recognized this was a problem. But here is a little clip from an email I received from a noted journalist, and I'm going to bet some of you out there have read some of his scientific stories in major newspapers when he wrote me and said, "Very angry group. Surprised there are no metal detectors to get in. Be glad you're not here." Because this is what was going on. Looking at the IAU charter, the IAU charter states, number one, they're to assign names to planets, moons, and other objects. Two, conduct educational outreach. Number three, assign unambiguous astronomical nomenclature. I made unambiguous a different color because I wanted you to remember that. assign unambiguous astronomical nomenclature. In 2004, feeling the heat from people that were writing the IAU saying, "Get your hands off my planet Pluto," it put together the IAU Planet Definition Committee. It was composed of some absolutely remarkable people. Andre Braik, the discoverer of the rings around Neptune. Ewan Williams, a British astronomer who worked on planetary evolution. Junichi Watanabe, Japanese astronomer working in asteroids and comets. Rick Binzel, I worked with Rick Binzel on the Pluto mission. He's an expert on Pluto and asteroids. And Rick also put together the Torino scale. If you don't know what that means, it means simply this is the hazard impacts of near-Earth objects that may hit our planet. This is how we determine how much damage they might create here on Earth. Catherine Cesarki, amazing European astronomer working with galactic structure. Davis Sobel. How many of you read so many of Davis Sobel's book, Longitude, Galileo's Daughter, The Planets, The Glassy Universe? And then there he is, Owen Gingerich, heading up this committee to decide what a planet is. They approached it from one of two different directions. They approached it from this question, what an object is. If we look at what an object is, it should be able to tell us if it's a planet or not. They also wanted to involve some historical nomenclature, historical history into our perceptions of planets. They worked for 2 years. But there was also another possibility as to how a planet could be evaluated, and that is where an object is located. Remember these two because we're going to come back to them. Either you decide what a planet is by the object it presents to you, or where that object is currently located. This is now where it gets political and interesting. The committee put together, to answer IAU resolution number 5, a planet is a celestial body that has sufficient mass to have formed into a round shape. It's a ball. B, it's in an orbit around a star and isn't another star nor a satellite of another planet. It was a pretty simple description. And if you took a look at this, you'd say, certainly Pluto's a planet. And so is Xena. It's a planet. Our solar system now has more planets added to it. Hooray, let's celebrate. But if you went back to my definition as a kid and just changed the sun to a star, a planet is a round ball that orbits around a star. We have the perfect definition for what a planet is. And then the dynamicists got involved. I will share with you something about education coming from a corporate world where we put together the smallest group of experts to solve a problem so that we could move quickly, to the educational arena where you could never have enough people on the committee. You may never reach a resolution, but everybody was heard and everybody's voice was added into the problem in trying to figure out what to do. That is a classical observation of a committee that may not go anywhere. However, the dynamicists were another growing group of separate astronomers, astrophysicists, that looked at objects in outer space very differently. They did not look at what the object was, they looked at where the object is located. So, when Owen Gingerich and his crew came to the IAU meeting and put their proposal forward as to what a planet was, it was turned down. The dynamicists were not about to have this definition go into the books as to the definition of what a planet was, because their voice had not been heard. They had not been included. They were not part of the process to decide what a planet is. Which brings me up to this very interesting quote I love from Abraham Lincoln. A man always has two reasons for doing anything, a good reason and the real reason. Let's talk about the real reason of what just happened here and the results of it. You need to understand an IAU meeting lasts about 2 weeks. People come from all over the world. Their membership is huge, well over 10,000, close to 11,000 people. And for 2 weeks, they discuss science, they discuss astronomy, they discuss latest discoveries, they discuss where they're going to have dinner the next night, they discuss where the next meeting is going to be 2 years later. They discuss all of this. And by the end of a meeting, the attendance starts petering out. People start going home. All the important things have been discussed, except the dynamicist group stayed behind. They had their meeting following the big IAU meeting, so they were staying in Prague. And they immediately called 2 days before the end of the conference for a new vote, whether or not Pluto was a planet or not. And they voted. I got to tell you, I've looked at this picture 1,000 times. Look at the expressions on some of these voters' faces. Look, take a close look. Some of them are pretty smug. Some of them are not happy. There was a lot of emotions around this vote. And calling the vote, it looked like this. Yes, 237 voters said Pluto is not a planet. No, 157 said it is a planet. 17 abstained. So you may look at those numbers and say, well, it was a vote, it was fair, and Pluto was demoted. But hang on there. The total membership of the IAU is 11,000 members. None of them were allowed to vote. Well, they could have put this online. They could have waited a week, 2 weeks, gathered all the votes, tallied it up, and said, we've come to a decision. But they didn't. You had to be in the room at that time to vote, or your vote did not count. So less than 4% of the membership was allowed to vote. And to me, this is no different than the state of Delaware one night deciding who the president of the United States is going to be, and you had to be in Delaware to vote. And if you weren't, you didn't get to vote. They decided who the president was. And that's how Pluto got demoted. Whoa. They had justifications. They had justifications on the fly that they had to put together so quickly because they maybe had not really thought this thing through. Their first justification for the press was this: there would be too many planet names for kids to memorize if we keep letting all these new objects in as planets in our solar system. And, you know, I really hearkened to that, but you know, it didn't work when we had to name and memorize the 50 states of the United States, or the 46 presidents we've had, or the 118 elements that are in the periodic table. Nobody said, you know, we should drop these down to 7 or 8 so kids have it easier in school when they had to do memorization. All right, so the next justification was there may be 20,000 of them out there. Good, I could see that. That's reasonable. But since that date, we've only added between 6 and 8 new members to this field. And so consequently, I haven't seen anything close to 20,000 being added in the last decade or so. So maybe there aren't as many out there as we originally thought. So the IAU came up with this reasoning and definition of what a planet is. A planet is an object in orbit around the sun. This is taken from their page. Self-gravity has pulled it into a round or semi-round shape. It orbits a clear path around the sun. There are no other bodies in its path that it must sweep up as it goes around the sun. Look at that. The sun, the sun, the sun. It only applies to our solar system. It means nothing as a definition for any other solar system out there in the galaxy. It only applies to us. Now, I don't know if they did this on purpose to add insult to injury, but then after they decided Eris or Xena was not a planet, they decided to rename it because that's part of their duty. And they named Xena Eris. They call this new object Eris. Now, for those of you that love Greek mythology, you got to be smiling right now because you know Eris is the goddess of discord. This is the only goddess that created messes wherever she went. Let's go back and take a look at our Greek mythology a little bit. The Greeks were throwing a big wedding. It was a huge wedding. All the Olympians were invited. It was the wedding of Peleus to his wife Thetis, which, by the way, it looks kind of like they're on their honeymoon already in this painting. But it was a big wedding and everybody was invited except Eris because she caused too many problems. Her sister Harmonium was there. Eris was left out. Now you can see Eris in the upper left of this painting. There she is. Look right there, leaning down on the rock, and she's throwing something into the middle of this group. It happens to be a golden apple. And inscribed on the golden apple is "To the fairest one." There were a lot of egos at this wedding. And "To the fairest one" caused some confusion. Who warranted the golden apple? Well, other members that were there. Zeus said, you know what? I'm going to hand this one over to my right-hand man, Paris. Paris, the Prince of Troy, is going to solve this problem and decide whether it's Aphrodite, it's Athena, or it's Hera. Which one of these three are the fairest and get the apple? Now, all three, Aphrodite, Athena, and Hera, offered Paris something, but Paris was smart. Aphrodite offered something the others could not. Aphrodite offered to Paris, if she got the apple, the prettiest human being in the world. Her name was Helen. And if she got the apple, Paris would get Helen. And so, look at him giving that apple to Aphrodite. It's hers. And of course, at the time, nobody bothered to mention that Helen was married to the king of Sparta, Menelaus, and that created the Spartan War and destroyed Troy. So here we are, a little bit of history, and the decision to name this object the goddess of discord fit perfectly. But moving ahead, there's something else that happened that's a little concerning. Remember my famous quote by Abraham Lincoln, "A man always has two reasons for doing anything, a good reason and the real reason"? I like this quote even better, from Will Rogers. People who get angry invariably make bad landings. Let's take a look at the bad landings this decision created for the IAU. First of all, the definition of what a dwarf planet is. Here is their definition. A dwarf planet is a small planet that isn't a planet. It's a dwarf planet. Say that over with me. Come on, everybody, say this with me. A dwarf planet is a small planet that isn't a planet. It's a dwarf planet. When I read this, kind of made my head twist around a bit. Because dwarf planet, in this sense, is a double noun. It's not an adjective modifying a noun. It's a double noun. It's a proper name that may not necessarily mean what it appears to mean. Just as many of us who have sat down and tasted Rocky Mountain oysters have decided that they may not have been from the Rocky Mountains and they're not oysters. It was the same type of name. When I asked a European friend of mine why we shouldn't take dwarf planet to mean a small planet, he said, what we call a dwarf planet does not mean the same thing in English. What? The second most spoken language in the world besides Chinese? It doesn't mean what it's supposed to mean in this language? Then what the heck does it mean? It made my head do this.
Of the Holy Cross of our Lord Jesus Christ, who lives and reigns
Yep, that's what it did to my head when I heard this definition. So let's play the duh quiz. I put this together because it was fun to see the reactions from people who supported Pluto not being a planet. I would say to them, are dwarf galaxies small galaxies? The answer was yes. Are dwarf stars small stars? The answer was yes. Are dwarf fruit trees small fruit trees? Answer was yes. Are dwarf bunny rabbits small rabbits? Of course, the answer was yes. Are dwarf human beings small human beings? Yes. Are dwarf planets small planets? No. All right, let's do it again.
The sign of the Holy Cross of our Lord Jesus Christ, who lives and reigns with the Father and the Holy Spirit. Damien.
Yeah, that's what it did to my head too. So using the IAU's definition of what a planet is, I can show you what a planet isn't using that definition. A planet is anything discovered in the Kuiper Belt, because there's no way to tell in the Kuiper Belt whether or not this object has cleared its orbit yet. We simply can't see the objects to determine whether it has done that. So even if this mysterious planet 9 ever shows up, it may not be a planet because we won't be able to tell whether or not it has cleared out its orbit. Any object in the process of forming around another star, we call them protoplanets, but are they? We don't know. We don't have a definition for what a planet is. Any object orbiting a distant star, how do we know if it's cleared its orbit? We don't know that. Any planet thrown out of its orbit and now traveling through space by itself. Definition doesn't work. And lastly, sadly to think, the objects Venus, Earth, and Mars are obviously not planets. How do I know that? Oh, I'm going to use the IAU data to show you. This is one of the most remarkable animations I ever received from the Minor Planets Center. I want you to pay close attention to it and watch why the objects Venus, Earth, and Mars obviously are not planets. What this shows are the asteroids being discovered and tracked in the asteroid belt starting about 100 years ago. And every time the white lights light up, these are new asteroids that have been put into the record books and monitored and tracked. There's our solar system. The sun is in the center, Mercury, Venus, Earth, and Mars. Going around in their orbits, you see a few of these asteroids coming in close, but just wait. As our instruments and surveys get better, every time these asteroids light up, new objects are added to the sky around us. Watch the orbits of Earth and Mars and Venus. The red objects that you may be able to see, they'll become brighter, are objects that could collide with us. More are added. Now we're really beginning to map the asteroid belt. It's becoming clearer to us. As more data rolls in, it becomes brighter and more predominant. And you see the asteroid belt forming now. Look at all those asteroids buzzing in around Mars, Earth, and Venus. More are added. The asteroid belt grows in prominence. Now look at all the asteroids encroaching on our orbits. There it is.
David, I think you might
Ah,
need.
sorry,
We'll just wait till the processor opens up again.
What?
David, if you can hear me, I think you might be frozen. At least your presentation is from our perspective.
Here,
Perhaps move to the next slide to clear up a little bit.
yes.
We're buffering. We are experiencing some operating difficulties. Please stand by. Thanks, Tom. That sounds about right. David, again, if you can hear me, we seem to be frozen.
Okay, I've moved ahead and
I can hear you now.
everything's fine on this end.
All right. Maybe move to a slide that without video on it and see what happens.
Sure. Are we there?
We are, yes.
Okay. Here's the problem. I showed you a little clip. You may have seen it, you may not, but the famous clip from Star Wars where they're flying the Millennium Falcon through all of those asteroids and the TIE fighters are getting smashed by the asteroids as they went through. We have a perception that the Kuiper Belt and the asteroid belt look like this, and they don't at all, which really relates back to clearing its orbit. We have now sent 1, 2, 3, 4, 5 spacecraft through the Kuiper Belt, all the way through it into outer space, and not one of them ever encountered a Kuiper Belt object. New Horizons is the only one that did, Arakoth, but that took us into the Kuiper Belt, billions of miles. We've flown through it now for 6 years, and we've not encountered another Kuiper Belt object. I had one of my scientists friends explain to me that if you were standing on Arakoth and looking any direction around you, you would not be able to see one other Kuiper Belt object in there. So the idea of clearing your path seems a little odd when in fact all these spacecraft can fly through and never have to clear their path because they never encountered except one object through the entire Kuiper Belt. So when you have a planet in the Kuiper Belt, what does it mean that it hasn't cleared its orbit? It's a little perplexing. By the way, this is what Arakoth looked like as we flew past it on January 1st, 2019, and realized the spacecraft was traveling at 32,000 miles an hour. And if while we were in the Kuiper Belt, we had hit anything even remotely larger than the size of your little fingernail, it would have destroyed the spacecraft. We found nothing. Here's a picture that was recently taken by the long-range reconnaissance imager Lori aboard the spacecraft. That yellow circle is where Voyager 1 left our solar system as it passed through the Kuiper Belt. All those bright objects you see are stars, except one at about 9 o'clock that's a little fuzzy, and that's a distant galaxy. So as we fly through the Kuiper Belt, there's nothing there. There's nothing in front of us. So the Kuiper Belt is more dispersed than anybody possibly ever imagined. And because of that, it simply means, going back to the definition of what a planet is an object that formed in orbit around the sun. Change that to star, and it works. Self-gravity has pulled it into a round or semi-round shape. That works. But this last piece, it orbits a clear path around the sun. There are no other bodies in its path that it must sweep up as it goes around the sun. Doesn't work, because the Kuiper Belt is more dispersed than we ever imagined. And there's no way to apply this principle to a planet. And there's no way to apply it to exoplanets, planets outside of our solar system. A planet that orbits a star outside their solar system, according to the Oxford Dictionary. And so far, ladies and gentlemen, we've discovered at least 4,000 of what we call exoplanets, even though we really don't have a definition for what a planet is today. So to resolve that problem, I would say this. Let's listen to what some of the astronomers at Harvard say about this definition of what a planet is and how it affects their work. Dr. Scott Kenyon, planetary orbital scientist, he says a planet is a round object orbiting a star. Cleared its orbit is a term dynamicists use. It's imprecise because orbits are rarely cleared. It's also time dependent. An orbit cleared today can become uncleared tomorrow. And it's impossible to extend the IAU definition to other planetary systems. Oh, how about David Latham? On the Kepler team, the test science team member, he's also discovered an exoplanet. He says a planet is a spherical object orbiting a star. The IAU definition was poorly conceived, does not apply to the planets around other stars, so I pay very little attention to it. Owen Gingrich, head of the planetary chair of the IAU definition committee, a planet is a spherical object that does not shine by its own light and typically goes around a star. Clearing its orbit was a concept driven by ego and pressure to come up with something by the end of the session. It was an unwieldy and very unfortunate concept. Oh, it gets better. Here's David Charbonneau, Harvard professor, planetary discoverer, director of the M-Earth project, looking for Earths around M-stars. He said, I don't know what the real definition for a planet is today. My colleagues ignore the cleared its orbit definition because it makes no sense. How much do you need to clear before you've cleared your orbit? Dr. Dimitar Saselov, Harvard exoplanet discoverer, director of the Harvard Origins of Life Initiative. A planet is a round object illuminated by reflective light that initially orbit a star. The IAU definition does not work when applied to other solar systems or rogue planets that have been pushed out of their solar systems. Dr. Mark Sykes, CEO and director of planetary sciences at the University of Arizona. Planets are round objects orbiting a star. The IAU definition only applies to our solar system. It tells us nothing about what a planet is as an astronomical object, and it doesn't apply to other solar systems. It's an unusable Earth-centric definition. Whoa, Alan Stern, planetary scientist, NASA Science Mission Director, Principal Investigator, New Horizons Project Director at Southwest Research Institute, 2007 Time Magazine's 100 Most Influential People in the World. It's an awful definition. It's sloppy science and would never pass peer review. A planet is a spherical body that formed around a star. If Earth was at Pluto's distance, it would be impossible for Earth to clear the neighborhood. Earth would not be a planet. Dr. Lisa Kaltenegger, exoplanet professor, director of the Carl Sagan Institute at Cornell. The IAU definition does not work for me and my field of study since it only applies to objects in our solar system. Studying exoplanets, we simply ignore this definition. Counting all of Kepler's discoveries, one of these days, the IAU will certainly have to revisit this definition and change it. And my observation is this: a planet cannot be defined by where it is located. Planetary orbits can change over time. All hot Jupiters and hot Neptunes we observe today migrated inward from the outer reaches of their solar systems where they originally formed. So classifying an object as a planet, depending on where currently is located, makes little sense. So what is a planet? How about a definition that is not ambiguous and applies to the entire universe? A planet is a round object that formed around a star. You're in, you're out, you're done. Yes, ladies and gentlemen, with this definition, Pluto is a planet, a dwarf planet, a small planet, not something exotic and different from whatever the name says it is. Sometimes in science, we have to take a look at what we believe at that time and what we may have to take a look at and change in the future. That's part of science. Science always changes. I know it drives some people crazy. You tell us something today and tomorrow you tell us something different, but that's just the way science works. And if you take a look at the great definition, Occam's razor, the simplest explanation usually is the best explanation. And the simplest here is a planet is a round object that formed around a star. So this is how we look at Pluto today. This is how we evaluate planetary objects. And in the future, the definition may change. And once again, little Pluto may join the crew. But that's science. And that's just the way science works. And it's okay by me if what I know today is changed tomorrow. In fact, I look forward to it because it means we've grown, we've learned something new. And if we can learn something new here and move ahead with a definition of what a simple planet is, because I hate to break the news to you, all of us live on one, it would be nice to know what the definition truly is. So we can help the IAU for people who may have gotten angry and made a bad landing. Thank you.
Thank you, David. Outstanding. As always. You're you never disappoint. I'm just a little bit unclear as to where you stand on this whole question, though.
I mean, look, what time is it? I'm a politician. I'll tell you where I stand.
All right. So I'm going to do something a little bit dicey here, as we still have so many folks left. I'd like everybody to enter into the chat whether when they start, before they came to tonight, I don't want you to answer it as after David's, but I want to know whether you believed Pluto to be a planet before we came in to David's presentation tonight. Can everybody go into the chat and let's just sort of take a vote. Did you believe it was a planet before you arrived tonight? We have lots of yeses. Now I'm just going to be a contrarian. I'm going to put no in there just to make sure that nobody's shy about. So there we go. We have genuinely people believe it was a planet. We have a lot of dwarf planets. David, I'm not sure if you can see the chat at this point.
I can't, but I'm okay.
Okay. We have most people saying yes, some with dwarf planets, some with a little bit of doubt, but primarily yes, it's a planet. And most of us probably went to school, I'm guessing, with Pluto being a planet. It's hard to get that out. I mean, unless you've been in school, in elementary school, probably in the past, 10 or 15 years, when this topic has been discussed. You went to school growing up thinking there were 9 planets. So
That's an interesting point, because that was one of the things that surprised the IAU when it was initially thought that they might demote Pluto, was the emotional attachment, and that so many people had grown up with it that it felt like the scientists were not considering that at all.
yeah,
And that was one of the reasons why this finally came to a vote, a very hasty vote, a very quick vote, a scary vote when you realize how few people actually determine such a big definition and topic.
mhm.
But that's how it happened. And it happened that quickly on the last day and a half of the conference, and it was done.
Sounds like a coup.
Sounds like politics.
Yeah. Okay, so what I'd like to do is to see if anybody has any thoughts or questions, and ask that you can certainly unmute yourselves, and be aware of if you're perhaps unmuted at the same time that somebody else is trying to make a comment or to share a thought, or to ask a question. So I'll open it up. Feel free to unmute, say your piece. Try not to get David angry.
They're stunned, I can tell.
Yeah, no, it certainly feels that way.
Yeah. They're all, actually, they're digging through their drawers right now to pull out their Pluto t-shirts.
In my intro, Dave, I said that you have a way of, presenting intricate material in such a way that makes it real within our own realm, and that certainly was the case tonight. With the number of graphics and the points you were making, even if I was a non-believer tonight, I certainly would have been swayed. I would have changed my vote. Nobody ever asks me though. So.
All right, are there any more questions? If not, I'm going to give you a fun little story.
Yeah.
I give you a fun little.
I'd like to ask a question if I.
Sure.
Oh, sorry. I wanted to know how big does an object have to be before it forms into a sphere from its own gravity? I'm sure it depends on composition, but is there a rough idea?
It depends on composition and mass. What I've seen is probably half the size of Pluto, which means it's probably in the 1,000-mile diameter. Don't quote me on that, because some of the smaller objects that we still have out there in the Kuiper Belt, KBOs, appear to be round, but we haven't verified that. So that has not been nailed down yet. And that's a very good question, because they're also asking that question in the opposite: how big can a planet be and not be a brown dwarf? Although brown dwarfs emit more energy than Jupiter does. So those are two fuzzy areas that we're taking a look at. But the crux of what I was trying to present in the reality is that of all the objects we can define from anything that's around us in science, how weird that the one we stumble over and have difficulty with is an object that we live on.
Yeah. David, we have a question from one of our international guests tonight from Latin America. Could you give us the definition of hot Jupiter and hot Saturn? You referred to that.
Yes, hot Saturns and hot Neptunes. One of the amazing things that we discovered when we started finding planets around other stars, that the big ones were the easiest ones to spot because they were so much larger than little Earths. But the reality of it, what confused us, is that the orbits we were finding these planets in were 17 hours long, 3 days long, 6 days long. They were literally orbiting their stars in 17 to 20 hours. because they had been pulled in from the furthest reaches of their solar systems where they have to form. They can't form close to a star. They have to form out there where it's cold, but they've been pulled in. They've migrated in, and they pushed every planet that was in front of them into their sun. And now they're orbiting around the sun. Some of them have huge cometary tails, materials spilling off of them. They look like giant comets going around their star. And soon they'll go into their star. They'll disappear into it. They're on a crash collision course. But we called them hot Jupiters, hot Neptunes, and hot Saturns because they were so close to their star. And some of these planets, oddly enough, we detected had rain on them. Dimitar Sasolov, one of the people I mentioned earlier, detected rain on one of these planets, but because it was so hot, the rain was iron. Iron droplets were falling from the sky onto the ground. Look out, there goes the umbrella. But so that's what they are. That's why we call them hot Jupiters and hot Saturns.
Excellent. Thank you. Hey, before we wrap up tonight, I'm going to put up a link here. If you like what you saw tonight and you're interested in making a donation to the Adirondack Sky Center and Observatory, which I should mention, David is a board member of our organization. I forgot to mention that earlier tonight, but he's one of our great board members. If you like these presentations, the Cygnus series wraps up next month. Actually, is our last in the Cygnus series, December 2nd. Jeff Miller from St. Lawrence University, Bye Bye Bennu, will be his talk on December 2nd. And we'll start our Orion series up after the new year. But I put up the link there for donations if you're interested in making a donation. We are attempting this Astro Science Center where we can do much more of these presentations live, virtually, for all sorts of audiences, as you saw in the video when we started this morning or this afternoon. So with that, unless there's any lingering questions out there from anybody, we'll wrap things up. David, I want to tell you how much I enjoyed your presentation tonight. Like I said, you never disappoint. More than just informative, more than just educational, more than just entertaining. It ties these very complex thoughts and issues into very nice packages that we can understand and handle without having the PhD, at least in my case, to make them real for us. So thank you so much.
It's a pleasure. It's fun. It's great to support the Sky Center.
Thanks. And with that, I'll say goodnight to everybody. Again, look for this video if you missed part of it or came in late or want to hear part of it again. We'll be on YouTube before the end of the weekend is always my goal. So thank you, and we'll see you on December 2nd. Bye Bye Bennu with Jeff Miller. Thanks, everybody. Have a great night.